No, we're live. Let's see. Okay, let's get this. Try to get this chat window over here. I'm not seeing the chat window. Chat window. Hmm. Not seeing anything in the chat window. So, what do you see? Do you see anything? Oh, really? Okay. Let's see. Yeah. This is really a test. I'm trying to do a live streaming class effective Thursday. So it might be up for a while. I'm going to try to work a problem. So I'm trying to get familiar with this OBS software. So I'm going to be working on a problem. I'm kind of working with my daughter. She's going to kind of see how things are going, but I don't see a chat window anywhere. So she has to tell me what you're seeing. Okay. Well, I'm going to work that out later. I'm going to have to run that on another computer or something like that. Okay. So here, I'm going to try to work a problem. Melissa, can you see what I'm doing there right now? You see where it says increasing, decreasing, extrema. Is this what you're seeing?
Yes, but I'm behind.
Okay, that's fine. I don't mind if you're behind. Okay, what I'm going to do is look at this problem right here. Y equals 2 cosine x minus x square root 3 on the interval from 0 to 2 pi. Now, what we're going to do is we're trying to find the intervals for the function increasing and decreasing, and we'll justify our answers. And then B, find the relative extrema values and where they occur. Justify your answers. So what would you do for this? And you can just tell me verbally because I'll assume we get this chat window set up later or I'll run it on another computer or something. What would be your first step on this one?
Sorry, I'm just behind.
What would you do this one the first? What would be the first thing you do to this? Okay, first step would be to find a critical number. How do we find a critical number of this function right here? Okay, critical number will be where the derivative of this function is either equal to zero. I'll just write here critical number where in this case y prime is equal to 0 or y prime is undefined. Okay, so what will we do for this one? Let's take the first derivative of this. So y prime is equal to, what is the derivative of 2 cosine x? Negative 2 sine x. And I'm going to have that chat window going here, maybe even if on a separate computer. And what is going to be our derivative of x squared to 3? Negative x squared to 3. What's that going to be? That's going to be square root of 3. Okay? And so we're going to set this derivative equal to 0. So 0 equals negative 2 sine x minus square root of 3. So if we go ahead and let's say square root of 3 is equal to negative 2 sine x, and so sine x is equal to what? Negative square root of 3 over 2. So on this interval here, where do we have sine x equal to negative square root of 3 over 2? Okay, we got, let's just go ahead and draw this out. We got our unit circle, and we have this business here. And so we want where we have square root of 3, negative square root of 3 over 2, which is going to be just down here, right? So in quadrants 3 and quadrant 4. So this is going to be x equals 4 pi over 3, and what else? 5 pi over 3. Okay? Does that make a little bit of sense there? Okay. Okay, let's go ahead and take how are we going to evaluate where the function is increasing and decreasing? I will show you. What we do is we make a number line, and we put our critical numbers on here, which are going to be 4 pi over 3 and 5 pi over 3. And we're going to put y prime up here and y down below on the number line. So the first thing we're going to do, and we're evaluating this function right here, this y prime function, and we plug in values. Well, we know that we're only going to have the possibility of changing at these critical numbers. So what we do is we pick some kind of value here between 0 and 2 pi. So we can just pick 0, right? So let's just pick 0. So if we pick 0 and plug in 0, we plug in 0 for what is sine 0? 0, right? So we get 0 minus square root of 3. So that's going to be negative in this interval, which means the function will be decreasing, right? And then the next critical number we can pick is right in between 4 pi over 3 and 5 pi over 3, which would be here like 3 pi over 2. So if we put in 3 pi over 2, what's going to be negative 2 times sine 3, 3 pi over 2, so negative 2 times negative 1 minus square root of 3. So that's going to be 2 minus square root of 3, which is going to be a positive number. So that means we're going to be positive in this interval, right? So our function is increasing, and then we're going to decrease because we're going to have another change. If we put in 2 pi, we're going to get the same thing we got for 0, right? So we're going to be decreasing here. So y, or we'll put in function, is decreasing, my writing isn't very good, on these intervals here, 0 to 4 pi over 3, and union 5 pi over 3, 2 pi. And why is that? Because y prime is what? Less than 0. And then we know we're going to be increasing in this interval. And I'm going to write over here, increasing on interval from 4 pi over 3. I think my resources on this are pretty well used. I think that's part of my problem. I'm not getting mine. Maybe I can do something with my rate on this, because y prime is greater than 0. Now I'm kind of running out of room for the test purposes. Where do we have a relative minimum? Here at 4 pi over 3, because what happens? There's a change. F prime changes from negative to positive, and a relative maximum is at 5 pi over 3, because F prime changes from increasing to decreasing, right? Or from positive to negative. So I want to go ahead and graph that on a calculator and see what it looks like. So we do our calculator, and we are in radians. So let's graph that. We have, I remember what it is, 2 cosine x, 2 cosine x, and that's going to be minus x squared root of 3. Was that it? Okay. And we'll graph it. We'll get a window. We'll start from 0 and go to 2 pi, right? That way we're going to see everything. The next scale, we're going to put pi over 3, because we'll be able to see that. So X scale, pi over 3. And y minimum and maximum, I'm going to put -3, positive 3. You should be able to see everything here. Here we graph it. Let me see. Yeah, I'm going to have to get a different window here. Increasing, decreasing. Let's get down to negative window. -10. See if that helps us. Okay. So it's kind of looks like this is going to be you can see it's the critical is right in here. We're decreasing all the way down from 0 to 4 pi over 3, and then increasing all the way to 5 pi over 3, and then decreasing from there. So so it looks, if we get the, let's go ahead and see if we can hone in the window a little bit better. I'm going to go from like -9 to -6, -5. You should be able to see it better here. Yeah, a little better. So you can see that, right? There's our relative minimum, there's our relative maximum. So it just, and then if we took the derivative, we'd be able to see it right there. So anyway, have you been able to, Melissa, hear me? But am I behind about half a minute?
Yeah.
Okay, good. Well, I got to get that chat window working somehow. So I'm going to go here to this thing. And how do I do this? End stream. Okay, very good.
This is the chat.
Melina? Okay, Melina. Good to have you here. This is a preliminary for my live stream class I'm going to be having on Thursday at 2 p.m. So thanks for helping troubleshoot this for me. And I'll try to keep this up for a little while anyway. I appreciate you being here with us.